When you walk away from this class, you'll understand the overview of what object-oriented programming is, why it's important, why we use it, why you would want to have something like classes in a programming language, and then you're just going to understand the essentials of object-oriented programming in the context of JavaScript. So whether you're writing code on the front end or the back end with something like Node.js, this will be helpful for you. All right, so encapsulation just means that we can take a bunch of data and then functionality for that data and bundle it all together into a single entity. That helps us keep things more organized, more reusable, more modular, all the things that are beneficial for writing code that scales, code that's easy to read, code that runs properly, code that's optimized, code that doesn't have too many errors, hopefully no errors, code that is easy to debug, and so on. So abstraction is just the concept of having a whole bunch of logic and implementation for a certain something abstracted away from us. So we don't have to worry about how it's done, but we have access to little bits and pieces that make it easy for us to adopt that functionality within our code. So think about like a library. Let's say you use something like Tailwind for CSS or Bootstrap for CSS or whatever. You bring in these different libraries and modules into your code, and you don't know all the code that was written to make those libraries work. You just know that you can call these different methods and just use the different syntaxes to make your life easier when you're writing code. So this applies to things like React library or Angular framework, so on and so forth. You don't know how any of that stuff works behind the scenes, or maybe you do, but most of us don't. And it doesn't matter because the writers of that code have exposed bits and pieces of it via methods and properties and other things that allow us to make use of it without needing to know how it was implemented. So that's abstraction. Inheritance is the ability to share properties and methods across multiple classes. So if you think of a parent class that has a defined set of properties, we'll talk about what properties and methods are in a second, but define properties and methods, and then you just want to augment that to some degree, then what you can do is you can inherit from that parent class with what's known as a child class, and it'll get all of the properties and methods from the parent class, and in addition to that, you can add new ones for the child class. So just an example of that so that you can kind of visualize it is, let's say that you have like an automobile class, and you know that all automobiles or vehicles or whatever you want to call them are going to have like 4 tires, and they're going to have potentially 2 to 4 doors or maybe 5 doors. They're going to have an engine. They're going to run on gasoline or diesel or electric. All these different things that can be encapsulated inside of this class of automobile. But then as you get more dialed in or drill down into the specifics of that, whatever it is, maybe it's a car, maybe it's a truck, maybe it's a tractor, you want to have additional classes that inherit all those things that all these different automobiles share, but then also has its own set of properties that are maybe more specific to that thing. Like maybe it's a sports car, and so it has things in the sports car that you wouldn't have on like a tractor or a truck. And so then you can have a sports car class that, rather than rewriting all of that code, right, we don't want to be wet, write everything twice. We want to be dry, do not repeat yourself. And so rather than repeat all of that code that you already have somewhere else, you can just inherit from that parent class. Now you get all of those properties and methods from the parent class in this new sports car class. And then on top of that, you can add some cool things like turbo or whatever else you want. All right, so that's inheritance. And then the last thing is polymorphism. So the word polymorph is Greek roots would be poly is many, and then morph is form. So we're talking about something that takes on many forms. And so traditionally in coding, if you had like a function with a single name, and you could give it different variables, different input, and have it give you varying outputs based on that input, within that function, you could have like a series of if statements with varying conditions or a switch statement with varying conditions. And it could get pretty long depending on the number of inputs that you allow. And for each of those different inputs, you just check, what the type of it is or what it is or whatever the case, and then you give output based on that. So that's one kind of quasi example of polymorphism, but within the context of object-oriented programming, what we have are a couple different methods available to us. Not so many in JavaScript necessarily, but in languages like Java and C# and Python and so on, you have a couple more. But within the context of object-oriented programming for JavaScript, we can do things called method overriding, which we're going to get into the specifics of properties and methods in a minute. But essentially what'll happen is, in the example a moment ago where we had automobiles and then we had like a sports car over here, or we had tractors over here, or we had, minivans over there, these varying classes that are like subclasses or child classes of this parent class automobile, the automobile might have a sound that it makes, just a generic sound. And so in order to get that sound outputted, we would just invoke a function, or what's called a method, on an instance of that automobile class. We'll talk about what instances are, but essentially on some object. And we would just get some generic output sound. Maybe it's just like vroom or something like that. But as you get into these subclasses or these child classes of things like the sports car, the sound is definitely going to change, right? And it's potentially going to change based on the type of motor that's used or whatever it is. And so you can have a method called makeSound that is inherited from the parent class, used within the child class, but then you can override it with a new definition of that same method, same name, but on the child class. And so while the child class still inherits all the other properties and methods from the parent class, this specific method or function is going to have its own functionality, its own output. So that's polymorphism. That's inheritance, abstraction, encapsulation. That's a lot of talking. So let's go ahead and write out some code and see how this stuff works. And then also while we're writing it, we'll come across varying concepts that I can explain more clearly as we're giving code examples. Okay, so the first things first, we want to know how to define a class, right? So there's multiple ways. There's class expressions and there's class declarations. So it's just like with functions where you have a function declaration, you have a function expression. So the declaration syntax for functions is just like function and then some func, and then you just define the function. Classes are similar, except instead of using the function keyword, we use the class keyword. And then the difference here, again, is going to be with classes in that you name them with capital names. And so this is just a convention, very common in programming. You'll see it in most any language. And so let's go with animal. So this is super common. The use of, especially once we get into inheritance, the use of a parent class named animal and then some subclasses like cat, dog, bird, things like that. All right, so once you have the name of the class with the class keyword, then you just open up your curly brackets. Now the other method is literally just to use, so that's the declaration method. The other one is to use a variable expression here, so the assignment of the class definition to a capitalized variable name. Whichever you want is up to you. This is going to be like an anonymous class or whatever, and then it'll actually take on the form of capital A animal. And when we get to the console in a little bit, we'll see why that's important. But I prefer this syntax, and this is probably the one you'll see most commonly. So class, and then the name of the class capitalized. If you have multiple words for whatever reason, then you would just do something like that, where you kind of have a camel case, but the first letter is capitalized at the beginning of the word. So this may be familiar to you if you use like Mongoose, or which is MongoDB's wrapper for Node.js, and you're working with models. So models are typically built using classes, and so their names will be capitalized similarly to what we're doing here. So you can kind of connect the dots with stuff like that. Okay, so we have this class, and then we talked earlier about properties and methods. And so the thing about the class that we're defined here is that, I don't need these headphones. Class is like a template. right? It's like a blueprint. So here within the class, the body of code here, we're defining the template for all the instances. So if you've ever heard of the word of like instance or instantiate, creating a new instance from a class, that's what we're talking about. So with JavaScript, it's a little tricky because they have these pre-existing data types that are called objects, right? And then inside your object, you have your properties. And so you have like A is, whatever A is. And then you separate these with commas and you say something like B, and maybe B is a function. And so then if you have a function defined on an object, then that's called a method. So this is the abstraction of the existing object with prototypes so that we can now use this class syntax. So I'm not going to go into objects or the prototype. Feel free to read that stuff on MDN. I can share some links to those resources, but there's going to be some differences in these objects, these object literals that you've already probably used to creating, and the objects that are going to be created via a class. First of which is the type of object, or which prototype the object uses. In this case, because we called the class animal, any instance of the animal class will then be an animal object. Whereas this is just, I don't know why my cursor keeps doing that, sorry. This right here, this literal object, is just a object instance. All right, so we'll get rid of that. We'll go up here. Let's go ahead and dive into creating some properties. So the thing about classes is that whenever you create a new instance using the new keyword, the first thing that happens is a function that's defined within the class gets executed or gets invoked. And so that function is always called constructor. And so if you're coming from the pre-existing way of doing object-oriented programming, or OOP in JavaScript, then you're probably already familiar with the concept of constructor functions. And so this is kind of similar in that when we create a new instance of animal, this constructor function is going to get invoked. So down here, if we say something like const, and then, oh gosh, what's everybody's favorite animal? So let's just say a dog for now. So sorry, cat lovers. So dog is equal to new keyword is important here, animal, open close parens. And so you can see we're kind of doing it like a function invocation, but we have this new keyword here. And so what happens is this constructor function gets executed, and the result of this gets assigned to the dog variable. And what we end up with is a new animal object assigned to the dog variable. So we'll see that here in a moment. So, okay, great. What do all animals have? Right? So all animals typically have some of them have names. I guess domesticated animals have names. So not all animals have names, but we'll go ahead and do this for this example. So this dot name is equal to, and let's just say my dog's name is Loki. Okay. And then let's do another thing here. So the age. All animals are going to have an age, right? So we'll just assume this is years. We'll use a integer, a number, whole number. So we'll just say, okay, this dog is like 8 years old. And then all animals are going to have a weight. And again, this value, the metric could be, in the US we use pounds, so we'll just assume that it's pounds, but you could also have an additional property on here called like weight metric, and then you could set that to lbs or something. Or you could set it to grams or whatever, kilograms. So my dog's like 75 pounds. Okay, great. So what we've done is that every single animal that gets instantiated from this animal class is now going to have these properties of name, age, and weight. Now, what the heck is this? Well, if you've done anything with objects prior, then you know that this, within the context of an object, points to that actual object. But within the context of classes in JavaScript, this is pointing to the instance that gets created from this class. So this is not pointing to the class itself, it's pointing to this dog instance. So if you create a new animal instance and you assign it to the variable dog, this object that dog references or points to is this. And so this is going to have all these different properties on it. In this case, name, age, and weight are the defaults. Now, if you're looking at this, you're probably thinking to yourself, okay, every single animal we create is going to have the name Loki and the name age, or the age 8, and then the weight 75. And you're right. We don't want to do it that way. So we want to make it to where we can pass these in. So we'll create parameters on this constructor function such that when we invoke new animal, we can pass in these values. And so we can say name, age, and weight. And then all we have to do here is just replace these with, now we have access to these parameters as local variables within the constructor function. So we can say name here, we can say age here, and we can say weight here. By the way, if you haven't seen this syntax before for a function, you might be like, what the heck, there's no function keyword. Well, within the context of an object, now in the most recent versions of ECMAScript, you can write methods, which are just functions on the object as properties, without the function keyword. So it understands that this right here is actually going to be a function. And of course, within the context of the creation of a class, constructor is a special type of function that will get invoked whenever you invoke the class name with the new keyword before it. Okay, so here we go. We have this dog. It's pointing to new animal. And the problem here is that now that we've moved those hard-coded values out into parameters, we need to include some arguments whenever we invoke animals. So here is where we're going to move that stuff to. So Loki 8, 75. In that order, name, 8 years old, 75 pounds. Okay, so let's go and take a look at the debugger here. Open up this. Get out of my way. Am I not logged in? It's probably, this might be tricky if I'm not logged in. So we'll save. It looks like I am logged in. Cool. So in this case, let's see if we can go over here and see if we get, now that we saved it, we should be able to refresh it and get our debugger. Cool. Okay, great. So here's our debugger here. And it's essentially, if you're not familiar with debugger, anywhere where you put the debugger keyword in a JavaScript code or script, it's going to pause execution and allow you to examine the existing variables. So you can see on the right-hand side here, we have scope, we have animal, which is a class animal, we have dog, which is a type of animal, it's an instance of the animal, so it's an animal object. And if you open this up, you can see that the age is 8, the name is Loki, the weight is 75. We have all the information we need down here in the right-hand corner, but if you wanted to go over to the console, clear this out, Control L on PC, you can also just push this little button right here, or Command L on Mac. Anyway, clear out the console, zoom in a little bit so you can see, but within the context of the debugger, we have access to all variables that exist in the script prior to calling debugger. And that means that we can look at the dog variable. And sure enough, just by typing dog and pressing enter, I get access to, look, it says animal with a capital A, so it knows that this object is a special object. It's not a regular object, although you can see that its prototype is object down here. We're not going to get into that, but essentially, this is an instance of the animal class, and that's why it says animal up here with a capital A, and it has these properties, name, age, and weight. Awesome. So there, we've got this dog that is an instance of the animal. Now, why is this useful? This just goes back to the fact that classes are blueprints. So now we've got this code written once, it's reusable, it's modular too if we want to export it and use it somewhere else as an import. But now what we can do is we can go in and create other animals. So this one, we'll rename it to Loki, and then this one is Logo, my other dog. Don't worry, I have a cat too for you cat lovers. We'll put him in here in a moment. And so Logo, I don't know how old he is. He's a rescue. So we'll say 9 years old, and then he's probably like 85 pounds. Excuse me. Have something to drink on here. Oh, I drank it already. Great. Okay, so again, if I want to go out of here, I've got that debugger, and we can just clear this out. We should have access to Loki. No, we don't. We have to refresh. So it's I thought it was saving for us, but I guess it's not. Maybe there's a setting for that. Anyway, if we refresh now, it'll open up the, here it is. It opened up the debugger. I'm going to zoom out a little bit. We're zoomed in just a little too far. Let me just close some of these things that are kind of distracting. And we'll go ahead and close this, close that. I don't need these. These are from some other stuff. Close the breakpoints, and the call stack's kind of cool that you have access to that, but we don't need it right now. All right, so we're really most interested in this here, and this is the variables that are available to us within the context of this script that we just ran, this debugger. You can see debugger is paused, and so we have the animal class, and you can see everything it has inside of it. And then we have the instances logo and Loki. These are two local variables to this or they're global in the context of this program. But logo points to logo, which is a instance of animal. Loki points to Loki, which is an instance of animal. They both have their unique values. Okay, so let's talk a little bit about the code itself. What we've introduced thus far are these instance properties. So there's 4 different elements and 16 different variations of those elements, if I'm not mistaken. Maybe there's more than that. Well, I'll have to reference the documentation. But essentially, what we've created here are properties, okay? Now, when we want to add some functionality to our class so that instances of our class can do things with the data that is being assigned to the properties, those functions are called methods. We haven't defined any methods yet, but other than constructor, which is like the default method. And we can though. So we can do something like make sound. Now remember what I said, the newer syntax, I don't have to write the function keyword. I don't have to do, because this isn't just an object literal, this is a special class syntax. I don't have to put in a property with a colon and assign it with comma delimiters, anything like that. I have my constructor up here, and then just down below it, you can use some empty space to make it easier to read. We can write another function. In this function, method, interchangeable words there, function, method. A function becomes a method when it is defined on an object, in this case, the class animal. So this one will be called make sound. Okay. Now here's the deal with this animal. We've created 2 dogs. What if we create a cat? Are cats and dogs going to make the same sound? Not necessarily. So for here, it might make sense to throw like a new error that just says something like generic animal sound. The other thing that we could do is maybe we could create a property called like this.type is equal to type, and then up here we could say type. You'll notice it was yellow until I put it as a parameter to the constructor, and now it's saying, oh, okay, I see, I needed that match, now I'm blue. So this.type is equal to type. So then what you could do if you wanted is you could throw a series of if statements in here, or maybe a switch statement in here that says, okay, if this.type is equal to dog, then my sound is ruff ruff, right? And that's fine. But depending on, I mean, there's tons of different animals, right? So you're doing that for every single animal. Your little class that was meant to be what they call skinny and small and encapsulated is now getting huge, and that can be a problem. It can be kind of hard to maintain. So how can we solve that? So what we can do is we can use something called inheritance. We're now realizing, okay, sure, all these animals potentially have a name, or they have an age, or they have a weight. By the way, not all animals have a name, so maybe we can do something like name is equal to null, or name is equal to undefined by default. And then if we give it a name, great, but if we don't, then it's just undefined. And the other thing is you can just declare the variable like that. So this is good practice to declare your instance variables within, or even your static variables. We'll talk a little bit, if we have time, about what those are in a moment. But it's good practice to define them, whether you define a default value up here or you just declare it. Sorry, that minus sign is supposed to be an equal. It's kind of a self-documenting feature, in that if someone looks at your class without having to dive down into the constructor or anything like that, they immediately know at the very top of the class, okay, animals have a variable within them called name that is potentially going to be used later. So you could have a default there if you want to. We'll just go ahead and leave that how it is for now. But anyway, what we want to do now is we want to introduce this concept of inheritance such that we can create some subclasses or some child classes to this abstract parent class that inherit all of these default values, but so that we don't have to define a type here on the parent class, we can just have the type be inferred by the class itself. So if that's not making perfect sense, let me go ahead and just write the code out and then you'll see, oh, okay, that's what he's talking about. So traditionally for Loki and Logo, which are both dogs, by the way, we've just been saying these two variables is equal to new animal, give me a new animal instance, and then here's these name, age, and weight. But what we can do is we can create another class, and this one can be called dog, and then rather than just opening and closing curly brackets and getting into the meat and potatoes of writing out the instance properties and methods, what we can do is we can use this extends keyword, and we can say that it extends animal. And so if a dog extends an animal, it immediately inherits everything that the animal class has to offer, including these values here, name, age, and height, weight. Okay, and so if you change this to dog, let's see what it does. So look at this. We have our animal class. Now we also have our dog class. And look, previously where Logo and Loki were saying that they were animal objects, they are now dog objects. But they're still able to use name, age, and weight. And we didn't define name, age, and weight inside of the dog class. Well, we inherited those from the animal class simply by putting extends on here. But now we know that Loki and Logo are dogs, one, because we created them with the dog class, but two, if we console log or print or run the debugger, any way of inspecting these two variables that we've created, we will see that the object type of these objects that are created from this instantiation of the dog class are type of dog. Okay, and so why is this important? Well, we talked about make sound, but then we realized, oh man, if we're going to have a make sound method, it has to determine the type of animal. There's so many different types of animal that can inherit from or can be created from this animal class. So it makes sense to create subclasses for each different type of animal such that if we create a new method here called make sound, it has the same name. This is polymorphism, right? Same name, different forms. So if you're calling make sound on an instance of animal, then it's going to give you a new error generic animal sound. But if you call make sound on a dog instance, well, guess what? It's going to execute whatever code is inside of make sound. Now there's two things you can do here. I'll focus on the more obvious one first, and then I'll show you this little tidbit of information that might be helpful. So first things first, let's just say return, and then what does a dog do? It's like bow wow or barks or whatever. Okay, so that's what this function returns. And so now, just because it returns, we're not actually going to see that, so we have to console log it. So let's go ahead and console log Loki dot make sound, open close parens. This is a function after all, a method. And then likewise, Logo, a different object, again, polymorphism, two different things, two different forms, the same method, but two different forms, and they, based on the object that they're called on, Loki or Logo, they're going to potentially do different things. Well, in this case, they're both instances of dog, and therefore they're actually going to do the same thing. But we'll see in a moment when we introduce a third class, a second subclass of cat adjacent to dog that inherits from animal, that the cat actually makes a different noise. So we don't need to look at the debugger for this one. We'll go ahead and comment that out for now. We can pop up this console down here, the built-in console, and sure enough, it's like reloading as I'm typing, so it should only do it twice, but because I saved it automatically, it's going to show it more than once. But here's the two most recent, and they are bow wow, bow wow. So the first one is for Loki, and the second one's for Logo. And if you want to differentiate you could do that here. You could actually say, this is what will make it different, by the way. So sure, they both say bow wow, but what if you go into a template literal here, you access this, and then you say this dot name says bow wow. All right, so this saves. Oh, look at that. Loki says bow wow. Logo says bow wow. So again, this is polymorphism at its core, and that is that we have one thing make sound, but it takes different forms. It has many forms. One form is Loki says bow wow. The other form is logo says bow wow. And like we're going to see here in a minute with our cat class, it'll say, my cat's name is Thor. It'll say, Thor says meow. Okay, so let's write that code. And we're going to do another class. This one's going to be called cat. Again, because we want to inherit from animal class, the parent class, we're going to use the extends keyword here. And then we're going to pass in the name of the class that we want to extend, or that we want to inherit from, which is animal. Okay. You don't have to include the constructor here. It's already included by default. Now there is something called super in case you wanted to add additional instance properties to the constructor function. We probably won't have time to get into that, but I will include plenty of links in the description of this video recording when we're done with this for those of you that want to do further reading to learn a little bit more about this stuff. Okay, so at this point, you're probably going, I know exactly what needs to happen here, right? Make sound. This is a method. Inside of it, we're going to return, and we can kind of borrow, oops, we can borrow some of this code here. So this dot name, right, because they all have a name because they all inherit from animal, even though we didn't include any instance property of name on dog or cat, we get that thanks to extends. So then we say this dot name says, and then the cat is going to say meow. All right, so I have Loki logo. I'm going to do another one here, and this is going to be Thor. But we have to change the class to cat class. Thor, I don't know how old he is. We'll just say he's 9. And then poundage, I don't know what cats weigh. We'll just say he's like 10 pounds or something. I think that's a pretty big cat. But all right, so then we need to replace this variable here. And we have each of these different instances making their sound, right? So different objects, same method name, multiple forms, polymorphism. Kind of a big long name, sounds fancy, but it's not a difficult concept to understand. Okay, so Loki says bow wow, logo says bow wow, and Thor says meow. Again, very minimal code, lots of reusability happening here. We have this new thing called cat, and it extended the animal class. All right, so what if we want the cat to have a different property than what is included with the existing one? So let me see if I can do this off the top of my head. Otherwise, I'm going to have to pull up the docs. But let's go to our cat definition. And at the top here, we can define our own constructor function. And then I think you just say, I think you still need to include the parameters. So name, age, and weight. So we'll do those. Name, age, and weight. And then I think you can just say super name, age, and weight. And so what super does is it invokes the constructor function on the class that whatever class you're inside of inherits from. So if we're inside of cat, it extends animal, and you call super with some parameters, it's going to invoke constructor. Hopefully this works and I don't have to pull up the docs here, but I can find it really easily if this is not going to work. So what if we include an additional argument? What do cats have? Let's say lives here. So cats, the whatever you want to call it, the myth or whatever legend is that cats have 9 lives. And so we'll just say this dot lives is equal to lives. And like I mentioned earlier, we can even say that lives is equal to some default value like 9, but maybe this cat has already died a couple times or whatever. Haha. So let's take a look at this and see, first of all, if it's throwing any errors. So we have our debugger down here. If it's working, we should still see everything the same. So let me make sure that I save this before we get into it. And we'll go ahead and clear this out and refresh and see if it catches it in the debugger. It looks like it caught it. There's Thor. Okay, so lives is undefined, and that's because it should have the default. I must have written that syntax right here wrong. I might have needed to use the this keyword. But anyway, we didn't pass in lives here. We only gave it 1, 2, 3 arguments, but now cat requires 4 arguments. So you can see how we're augmenting the cat from what it has by default with new stuff. So I think this is supposed to be this. We'll find out. No, it does not like that. I'm just going to leave this part out because I'm not remembering the exact syntax for it, and that's okay. We'll go down to here and we will include how many lives Thor has. So I'm going to assume my cat still has all 9 of his lives. And now if we save this, we'll go over here and we'll refresh. We should get caught in the debugger. And sure enough, look, this object, cat object right here, bottom right corner, now has the name, the age, the weight. Those were assigned because we did the super thing, which invoked the constructor function from the parent class, animal. But then we also have this additional property that the animal class does not have. And so we did that by augmenting it, creating our own constructor function within the subclass, which is cat. Okay. All right. So a couple of things I want to talk about before we get out of here. We got started a little bit late, so I can go a little bit late for anybody that wants to hang out extra. But there's lots to dig into with classes. We're kind of scratching the surface, but I would recommend doing some exercises either today or whenever you have some free time if you're interested in exploring this concept further. That'll kind of help solidify your knowledge of classes. So the concept that I want to introduce here is the concept of getting and setting. And so the nice thing about classes is they have what's called encapsulation. Now, in previous iterations of ECMAScript, we used to use specifically the prototype, and we would use the constructor function, and we would use something called closures, where we would have a constructor function with its instance properties defined within it, but then also a method defined within it as a getter and potentially also another method as a setter, so that the only way to get access to the instance properties of a specific object would be to call a method. Now, we have this new syntax that's similar to other languages, like Python, for example, where we can just indicate that a method is, or that a property is bound to a specific method. Okay, so let me just demonstrate so you can see what in the heck I'm talking about. All right, so the way things are working currently, let me see if I can just pop open here to get the console. All right, so if we look at Thor, get out of here, I'm in the console. If we look at Thor, there's Thor. If we look at Thor.lives, this object, this cat object, this cat instance that we've assigned to this variable Thor, has this instance property called lives that we can access publicly. By publicly, I mean we can literally just call in dot notation Thor.lives, and it'll say 9. That's fine in some cases, but in other cases, you don't want to make information that exists within the context of the class available to the outside world. Therefore, it should be private. Now, previously we did that with closures. Now we have access to a syntax that allows us to define that a instance property or even a static property are private. We haven't talked about static properties. We may not get to that in this lesson, but these are not private. They're public by default. So how do we change that? Or how do we just set up a pattern for getting the property and then also updating the property, right? So reading and writing to these properties on this object. So we're going to use the getter and the setter syntax. So for get, you just say get, and then followed by that is the name of the property that you want to bind. So it doesn't have to be any of these properties here, but it often makes sense that it is. So for example, if you say get name, and then this is a function, and so then it returns this dot name. That's it. Get name returns this dot name. And so where previously we said dot notation lives, and it gave us back the lives, you would do the same thing, assuming you had lives on here. We don't. We could do it for cat if we want to. But in this case, name, if we did, let's say previously before we introduced dog and cat classes, we had Loki and Logo as instances of the animal class, and we say something like Loki.name, it would give us the name. But now we're explicitly setting up a getter function that's bound to the property name. And so this will return this dot name. And this is just like a convention. But the reason we have it is such that we can, once we're dealing with private properties, we can keep them private, and we can also access them by specific methods. All right, so then setting that same thing, set name, the thing about this is that it has to take a specific argument, okay? So you could say something like new name, and then here you would say this dot name. So when you say this, you are accessing this one, right? And again, this points to every single instance created from the animal class. So Loki is a this, Logo is a this, and on those thises, you have these different properties. Name is Logo or Loki. Age is 8, 9, weight is 75, 85. So what we're saying is access the value of the property name on the whatever instance you're calling this name on, and assign it to whatever this argument that gets passed in for this parameter new name is set to at the time of invocation. We're not returning anything here. We're mutating the internal state of this object. If we wanted to get the name, then we would need to call name. Now, the thing that's interesting here is that while these are methods and they are invoked similar to a regular function, and the set method always takes one argument, and that's the value that's going to replace the value, the existing value, if there is one, for a specific property. The way that we call them is not the same way that we call methods. So I'll show you here in a second. Okay, so we got the debugger. Let's save this. Let's go over here and look at this. Okay, so we should have access to Logo. Might have to refresh. My console is not getting, we have an error here. Maximum call stack size exceeded. So something that I wrote here is not right. Oh, ha, silly me. Okay, cool. I should have known this. We did this the other day in our other lecture that we did. So when you use a getter and a setter for a specific instance property, what I've created here is like an infinite recursion issue because I use the same exact name as that property. And so what we have to do is then go to that property and put a underscore before it. So this dot underscore name is equal to name, and then down here, I'll put the underscore here, and here I'll put the underscore here. The other way to avoid that, of course, is just to name your getter and setter methods such that they don't use the same name as name. So it's up to you, whatever convention you use. So let's save this, and hopefully that gets us out of our little issue. And if we refresh, it should bring us into our debugger. All right, cool. So now let's go over to the console and play around. So if we say Thor.name, and here's what I wanted to show you all, is that you would think, oh, the getter is a function, right? It's a method. So therefore, once you say Thor.name like this, and it gives you this type error, Thor.name is not a function at eval. The answer is no, because when you use the get and set keywords, that is different to when you define a method like make sound, because it is binding that function to a property name with the name of the getter or the setter. And so this is the other interesting thing, is whenever we defined it, we defined the setter such that this dot name, you would think, oh, it took one argument. So if we're changing the name of the cat to, maybe the cat's name is Loki now too, how original, oh, that's not going to work either. And that's because you're actually setting the property to whatever value you want. And so in this case, this dot name is equal to Loki will then invoke the setter method, and it'll take Loki and it'll pass it into that method, and it'll update the instance property of name. So if I say this dot name is equal to Loki, and I say this dot name, now I use the getter to get the newly updated name, which is no longer Thor. And if we say Thor, the variable, dot make sound, we forgot to update our method here. So make sound, where are you? I think would also have to be this dot underscore. Let's see if that's right. We can also look at the entire object. So we have Thor. Once we refresh. Okay. So we go over to our console, clear out all this junk. Keeps putting me in sources. And we say Thor, and we have underscore name Thor. So if we say Thor.name, there's Thor. Thor.name is equal to Loki, except I messed up the, there we go, Loki. And then we look at Thor again. Oh, look, it's Loki. And so now if we say Thor.makeSound, Loki says meow. Okay. So a couple things to stay on top of is the naming. If you're going to use getter and setter methods, which you should, then they are being bound to the properties of the name of the method itself. And therefore you can have naming conflicts. And so the way to avoid that is to, within your constructor function, to use underscores when assigning those properties, or simply to name, you could say something like get name instead. And you could even do this one to set name, and then you wouldn't have to use the underscores. All right, so the reason that's helpful, of course, like in this context, you're like, okay, well, yes, we're following convention, but otherwise, it doesn't really seem like we did anything different. And it becomes really useful when you start talking about private properties. Okay. And so the difference between a regular property and a private property is that they will have a hash. They're called hash names. And so what you do is you just put a hash before the name, if I'm not mistaken, and that makes it private. And then it's only accessible, basically what it does behind the scenes is it creates a closure, and it's only accessible if you use a getter or a setter method. Okay. So we can go into the private variables or the private instance properties in more depth in a future lecture. There's other things too, like static properties and static methods, meaning properties and methods that exist only on the class itself, not the instances of the class, but the class itself. And so, for example, let's say you have like a calculator class, and the calculator had a constant property called pi. And so pi is never going to change. It's always going to be 3.14, blah, 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 blah. And then the calculator has an instance, or sorry, not an instance, a static method called, calculate area. And so when you calculate the area of something, it's just going to take like the width and the height, and it's going to multiply them together and return that value. So those could live as static properties and static methods on the class. In other languages, they're either called static or they're called class. I keep combining those together. They're called class properties or they're called class methods. In the context of JavaScript, we call them static. Okay. So two things, you have instance and you have static. Instance is going to be for every instance that you create. So if you have an instance property and you create a dog instance, then that property is going to exist on the dog. However, if it's a static property or method defined on the class, when you create an instance, you will not have access to those static properties or methods from the instance. They're only available on the class itself. And so to invoke them or to call them, you have to call them with the class name as opposed to whatever variable that you assign to the instance. So again, those are more advanced things. We can get into those in a future video. I'll go ahead and open up for Q&A. If anybody's stuck around, let me pull up. I have both chats in front of me. So for anybody that's still here, if you have any questions about what we lectured over today, please let me know. Just as a quick review, we have classes denoted with the class keyword, and they are capitalized. If you have more than one word, then they're capitalized with camel case. And then you're always going to have a constructor function which takes parameters. Those parameters are arguments that get passed into the class name whenever it is invoked with the new keyword before it, thus creating a new object or a new instance from that class. Those arguments get passed down into the constructor function, which then get assigned as either the properties or the methods of the instance. And so here you can see where we have this name is equal to name, this age is equal to age, this weight is equal to weight. Then you can assign outside of constructor getter and setter methods, which then are bound to the properties with the same name as the method itself. To avoid naming conflicts, you'll need to go back to those specific properties and give them an underscore before the name. Likewise, if you just want methods on the instance methods, then you just define them the same way that you define the constructor. No need for get or set before the method name or the function name. You just name it whatever you want. And then if you want to inherit all of the properties and methods from a parent class, then the sub or child class just uses the extends keyword in its class signature class definition. So then it's going to inherit everything. What you can do, excuse me, throat's getting dry, sorry, is you can override methods, and this is a form of polymorphism, is to create your own version of a method in a subclass such that whenever you call that method on an object from that subclass, it'll behave differently than the output of that same method on the parent class. And you can do that for each one of these subclasses that inherit from a parent class. By the way, you can inherit on inherit on inherit. You can do if you wanted the cat to extend the dog, you could, and then now the cat is extending dog and animal. So it just creates this chain, and that goes back to how this all works behind the scenes with what is called the prototype. So again, we have another child class here, and this one with dog, we didn't define the constructor function, but in cat, we wanted to augment the existing constructor function inherited from animal with an additional property. So we did that by adding the property after the existing ones, passing the existing ones into something called super. Super just is a way for us to call the constructor function from the parent class that the child class inherits from, and then we added an additional property from that parameter that we added here on any instance that gets created from the cat class. Likewise, we did some method overriding with the make sound method such that any instance of the cat class will have its own output, which differs from the output of, say, a dog or an animal. So thanks again, everybody, and hope to see you all next week. We got a couple different lectures happening on Tuesday and on Wednesday. Tuesday is going to be the second game development lecture with Andreas, and the Wednesday lecture will be with Josh, and he's going to teach us about the Laravel framework with PHP. All right, thanks, everybody. Hope everyone has a great day.